have experienced the present of MRI and learned from those who created it. But curiosity has no limits, at least for us. Learning is a never-ending journey. And as we stepped into Siemens Healthineers' manufacturing facility, we caught up a glimpse of what the near future holds. Visiting the place where the future systems are built was overwhelming. We needed some guidance. So we went looking for Roland Meyer, as we were super keen to ask all the questions burning in our minds. Roland invited us to visit the factory floor and showed us a brand new MRI scanner ready to be shipped to a client. It was an opportunity we couldn't pass on. Understanding the step-by-step of producing these MRI scanners that we love is something Julian and I always wanted to wrap our heads around. But Roland is the right person to tell us everything about it.
Roland, it's awesome to be here in the manufacturing area of Siemens Healthineers, looking at these futuristic machines and what goes into building one every single day. So I want to start by asking you, how is the process of choosing the components that go into building these machines?
Well, the components are defined by our R&D colleagues. But we are talking here about a magnet, so all the materials have to be non-magnetic. So if you would have a screw which is magnetic, like here in the patient table, you would see it in the images. And it's the same also for the electrical components, because we also talk about high frequencies and about power.
Absolutely. And can I ask you, on top of that, how do you actually do the quality assurance of those materials? So we spoke about how you choose them, the main principles behind choosing them, but then how do you test this quality of those materials as well?
So we have here our system integration, meaning that a lot of components are delivered to our factory and we do the assembly. So each component has been tested before by our suppliers. We do here again a test of all components brought together, electrical test, kind of function test, but certainly we can't do a final test because we have here no field, no magnetic
field. So basically, your suppliers do their own tests, then you test it here again. So there's a lot of testing going into these things, of course. And then I have another question to pile up on that. So when do you do the final test of the scanner? So you produce the scanner here, then you bring it to the client, and how do I know the machine is actually working well as it should?
At customer side, we do the ramp of the magnet and also the shimming process. So we have to adjust the magnet to the site conditions. And after that, we do our quality acceptance tests. So that would be the final tests. And if everything is right, then we can hand over the machine to the customer.
So you hand over at that point only?
Yes, only when everything is green, everything is tested perfectly.
Wonderful, yeah, makes sense to me. One last question for you, because this is amazing. How do you decide, for example, in this month, in this period of time, which scanner to build? You have so many scanners in your fleet. We have, for example, Magneton Vida here. We're probably building some Solo or Freemax. How do you decide which one to build in certain point in time?
So we are driven by our customers. The whole factory is based on customer orders. So it's a make-to-order process. And on site, it's also a construction area. When you have to bring in the system into a building, this is handled by a local project manager, and the local project manager gives us the date when we have to deliver. And calculated back, we start the manufacturing here.
Okay, perfect. So it's a purchase order that initiates the procedure of actually deciding what to build. Okay, that's awesome. I think I have everything we need. Thank you so much once again for hosting us here in this so special area of Siemens Healthineers. Thank you so much once again.
Pleasure to have you here.
We could have spent the entire day at the manufacturing area, but our journey wasn't over yet. Energized and excited, we headed back to the Med Museum to meet Stephanie, a product designer, who showed us what goes into creating the MRI coils of tomorrow.
Steph, we're back to the museum for this episode because we just spoke with Roland at the manufacturing area. He showed us how we build the scanners from scratch, and you are a designer. Right. We can see the old coils, the present coils, but I want to know what's into design something that we're going to use in the future. Okay. If you can tell me a bit about it.
I will try, right? It's still a big secret, of course. Yeah. Actually, the major point is that we want to develop relevant products for the market, right? So that is super interesting to talk to people, what they really need, you know, what the problems are. We are working in multidisciplinary teams, so putting up a future vision kind of also involves software workflow specialists from UX, and we also have, of course, a lot of industrial designers working on that topic. We are stepping into this problem of really, you know, developing coils that are more comfortable than today, of course. As you can see, I mean, in the past, they look very technical, very machiney. You don't want to have it on the body, and we know about that problem patients have. The new coils, of course, are more comfortable. They are more like a blanket, you know, wrapping around you. Materials are new, very soft, and of course, our future vision would be not to have any coils.
Any coils at all. That would be amazing.
That would be our vision, but technically not feasible right now. First thing is you need to have a very good image quality, right? So that is main target, and whatever we can do to promote this patient comfort.
So we're talking about patient comfort, which is a great point that we want to touch upon.
Yeah.
Is the fact that I believe do you have any focus groups with patients and staff, like radiographers, the boots on the ground that actually use these systems? Do you have those focus groups to get feedback from them?
Sure. I mean, this is mainly, you know, the starting point, because we need to understand their needs, we need to understand the problems users and patients have. We are going out with our colleagues from research to the hospitals, you know, looking at the workflows, environment, you know, how they put up the systems to really deeply understand. And within the whole process of developing the new product, we do a lot of exploration, validation, also with like short mock-ups, or, you know, just doing tests by regular customer involvements. So yeah, we want to make sure that what we do really has an impact.
Yeah, right? Fit for purpose, basically. So I want to touch upon this coil, not in specific, but the head coil kind of concept. We have, of course, a lot of claustrophobic patients around the world, right? This design's never been very helpful for claustrophobic patients.
True.
We know about, for example, in radiotherapy, we have that kind of swimming cap thing. Do you think that would be something that we could use eventually in MR in the future? Is that something that you at Siemens Healthineers think about on a day-to-day basis, or not really?
Yeah, we are constantly exploring in different directions, right? For now, I must say, we still stuck to this kind of structure because it gives the best freedom of patient comfort and, of course, of image quality, because that is what matters at the end. And this is what patients are doing, undergoing this examination, right? So what we do is working closely together with R&D, kind of expanding, you know, in the patient comfort direction. So we open up the coils as much as possible. We're also thinking about, you know, how this patient really, how the angle needs to be to lie comfortable on it, or how we can also have some kind of entertainment or infotainment within the bore, so patient knows how long it will take until, you know, it gets out again, or having mirrors to stuck in so they can see out. So this is for now our solution. I know it's not, you know, what patients would expect to have, but that is somehow the traction we have. And
I'm sure you're always looking into the future anyways to improve that comfort and to maintain that image quality at the same time.
We would like to get rid of it, of course.
Of course. I have one last question that actually came from our community, and I would love to ask you, because you were a designer at the end of the day, and that was one of the questions.
Let's see what it is.
That's one of the questions that people actually asked us a lot. It's why all the coils are white. The same for the scanners. Always white. There's never color in it, and people ask us, what is it? Sometimes makes it a little bit dull because everything is white, but I believe there's a reason behind it, and you as a designer probably have a really good reason for it. So I don't know. Could you explain a little bit if you know that?
So just to check into the Siemens Healthineers design guideline a little bit. So our products are not like only white, as you probably saw already, right? So what we do is we kind of layering our systems. We have a core color, which is a silver matte color, which is pretty unique. And this is kind of resembling the technology inside, the innovative technology. Then we have outer layers, which are more like patient-facing, which are white. And there is a stage element and also signature line in healthy orange, we call it, kind of binding this human part and the technology together to make it a Siemens Healthineers product. So that are the DNA elements. And of course we know that, I mean, seeing that this is a Siemens Healthineers product is not only the only focus, and people want to have different colors, but that also makes it pretty complicated because every hospital is different, right? You have different environments. So that kind of structure, it gives us the freedom that, you know, patient have this this one entry point, because there's a lot of things happening around
at the same time. Yeah, I agree.
And so this is calm. This is, you know, you can rely on this system being like the focus point. And of course white has different other reasons because of hygiene. You can clean it pretty easy without having, you know,
if you have blood you can see it straight away, or dust, even dust, you can see it. Makes sense. Yeah.
So hygiene is one topic, and I think it's just a neutral color, right? We want to go with to, you know, not distract people too much, but there is more in the pipeline, just to say that.
Perfect.
Because things are also changing in the hospitals.
Yes.
You know,
the whole environment is evolving.
Yeah, right. So this is why we also keep an eye on that, and yeah.
Perfect. Thank you so much. I appreciate, and I'd love to see what we had, what we have, and where we're going.
Where we're going.
I think it's really exciting. So once again, Steph, thank you so much for having us.
Thank you.
It's a pleasure.
By then, the Med Museum felt like home, but our final guest was waiting for us back at the Experience Center. And that's exactly where we headed once again, to meet Vincent Wong. Julian arrived just as Vincent was preparing some protocols to show us. What followed was a conversation that was nothing short of inspiring.
Vincent, it's fantastic being here with you to touch base a little bit on the future of Siemens Healthineers. Today I want to be the voice of the voiceless of that humble category that you know, radiographer, right? It's a category where it's very familiar for the two of us. You're one of us, you're a radiographer too.
That's right.
And I want to ask you, in your career as a radiographer, did you have one of those patients say, oh, I cannot really hearing clearly, the sound like it's a little bit muffled? So I want to ask you, why are we not able to switch from like these headphones that are based on compressed air rather than having headphones based on stereo, that kind of sound? Is there a reason for that?
Yes, this is true. So as far as I know, most headphones out there contain some kind of rare earth material or some kind of neodymium magnet. So as you can imagine, this is problematic in an MRI environment. Yeah? And therefore, for the longest time, we've been using these pneumatic headphones. I have to say they do quite a good job. Yeah? But basically what they have to do in general are two things. So they have to ensure that they reduce the noise for the patient, and also to transmit the audio communication between the technician and the patient. And for this, Siemens Healthineers has recently introduced with the magnetic flow comfort sound. And this is actually our wireless sound system, and it's integrated into the biometrics head neck coil.
That's fantastic.
Yeah, and it provides very clear sound and also communication for the patient. And it also has this specially designed pillow, which further enhance the audio performance. So the need to wear those bulky pneumatic headphones
so we can reassure
is a thing in the
our
past.
patients. Okay,
yes.
Fine. I know you're also very passionate about physics, right? And to be honest, we here at Everything MRI, we get a lot of inspiring students that want to learn a little bit more about MRI. And someone was telling us, but why do we actually rely on helium to keep the magnet at a superconducting state? Is there a reason why we don't use any other cryogens? Would you use any other cryogens at least?
Interesting question. So most of these superconducting magnets that we have today are based on the principle of low temperature superconductivity. This means that they exhibit zero electrical resistance when kept at ultra low temperature like 4 Kelvin. And to do this, we always have been using liquid helium because it has the lowest boiling point of any element, and therefore making it extremely suitable to achieve superconductivity. But besides that, there is a possibility to use liquid nitrogen. But the only problem is liquid nitrogen has a boiling point of 77 Kelvin, which is like minus 196 degrees Celsius, and that's not really enough to reach the superconductivity state. Nevertheless, it is more affordable and more abundant than helium, so it is sometimes used to pre-cool a magnet to save cost.
That's fantastic. Well, I think our students will be very happy to hear that. And the next question I wanted to ask you, I think you might find it quite interesting as well. I think you're into MRI education, right? So in our YouTube channel, we kind of like focus quite a lot about trying to achieve a better image quality. And one of the recurring topics that were always coming out was about like the importance of having a field that is much homogeneous as possible. So getting the patient at the center of the ball, for instance, or adjusting the shimming, you know, while performing the scan. But I want to ask you, why is that? Why do we need to do all of this? Why can't we just have like a ball which is like uniform, like fully uniform in each part of it? Is that a possibility?
Well, actually, the fact is, it is really impossible to manufacture a completely homogeneous magnet in the whole ball. Yep. And even with the most precise engineering, there will always be some minor imperfection. And we are really talking about very minor, like parts per million. But the thing is, actually, no matter how homogeneous the magnetic field is, the moment the patient goes in, the field is always distorted. So you will always have to do shimming, especially for certain applications like FETSAT or spectroscopy imaging. This is unfortunately unavoidable.
Vincent, I'm kind of excited because I can see you brought with you something which seems quite interesting, I have to say, from a radiographer background. So can you tell me a little bit more about that?
Sure. This is our biometrics contour coil. As you can see, it is very light. It's only about 490 grams. Wow. But most importantly is the size is actually optimized for certain use. For example, if you want to scan the wrist, which you typically have a field of view of, let's say, 12 centimeters, and this is perfect because this coil allows you to have the maximum coil density per field of view.
Wow, that's fantastic.
But that's not all. I think that's not all, because the most interesting thing is all these contour coils are equipped with smart sensor. So what it means is it's able to detect the physiological signal from the human body, for example, your respiratory signal or your cardiac rhythm.
Just with this tiny little thing?
That's right. And you can then use this signal to trigger your scan. Yeah. So meaning, for example, it's a reality today that you can do a complete cardiac exam, ECG triggered, without ECG.
You got my attention now.
Can you imagine? So because all this while, I mean, we've been doing cardiac exam when we know how we struggle with ECG, with the magnetohydrodynamic effect, and maybe you have to shave your chest if you're a bit too hairy. These are all a thing in the past because you don't need ECG leads anymore.
And what about I can see that is one that is even, you know, perhaps more appealing. What is that?
That's right. So as you can see, this is one of its kind. It's probably the first time you see that a coil, that comes with holes in it. So these holes are added for added flexibility of the coil. And most importantly, it reduces the tendency of warming sensation during imaging.
That's fantastic. I was just noticing how much you can wrap it. It's literally so flexible.
That's right. You can use it for body imaging, of course, or maybe even for peripheral, or when you are doing multi-station examinations. So this one coil is just perfect.
That's fantastic. I'm pretty sure our patients will be quite happy to see these new features and these new tools. Winston, thank you so much. It was amazing. Thank you for showing us a little bit where the magic is again.
You're most welcome. My pleasure.
Thank you so much.
Nice to meet you.
Julian left the room carrying a wealth of insights to share with the broader community. Don was waiting once more, ready to help us bring this unbelievable journey to an end.
Guys, what a journey. Jumping from the past to the present and then the future. My goodness, we witnessed so many things in this documentary. I really hope this was informative. What do you think, Sam? What did you take out from this experience?
It was an amazing journey from start to end. I think we have amazing discussions. We saw amazing technology, really good interviews. And I just want to thank you, Don, for having us. Thank Siemens Healthineers for receiving us so warmly. And I hope everyone at home likes what we are producing here. So once again, thank you so much for this.
Oh, you're welcome, guys. Thanks again also coming here to Germany. It's been a super fun day interacting with you, and I know the guys, the whole team's had a lot of fun with you. And hopefully we've got a lot of good material to use for your podcast and show the community, right, the exciting stuff that we're working on.
From a single idea to precise execution, from carefully crafted designs to moments that shape history, this is the magic of MRI. Ideas built Siemens Healthineers, ideas built Everything MRI, and ideas will shape what's come next. But ideas only matter when they're executed with passion, purpose, and love for the craft. Someone imagined it, someone built it, and that next someone could be you. And for that, thank you for exploring the world of MRI with us.